So welcome to our session. Our session is on deploying and designing Kubernetes with NSX-T. So if you are running like Kubernetes or PKS or even PAS in an environment, this session is actually for you, right? So this is the disclaimer slide. We're not talking about any roadmap features and all this, so we don't need to worry about this disclaimer, okay? And let us first introduce ourselves. I'm Vincent Han here. I'm a staff solution specialist at VMware, focusing around networking and security, and more recently on the cloud-native app space, right? I'm from Singapore, by the way, and I'm super excited to be here to speaking to all of you. Roy, introduce yourself.
My name is Roy Ben Chaim, and I'm an SDDC architect, focused around network and security.
So this is what we'll be covering today. We'll start off with asking the question why? Why NSX for container and container networking and security, okay? Then we will do something interesting here. We will do a role play to showcase the solution. So, I will be acting like a customer's typical, customers asking for a container solution, right? Then Roy will come in as a VMware architect to say, okay, with all these requirements, what are the solutions over here, right? So we'll do that, and then we also have a demo, but before we go for the demo, we'll talk about what's under the hood, what's the secret sauce in NSX to solve some of these challenges over here. Then we'll be covering, Roy has prepared a very, very cool demo, so do check it out. We will also be sharing some of the updates in NCP 2.5, right? Then both of us will come in and then share with you some of our experience in deploying some of the solutions in our customers' environment. Okay, and then we will have question and answers. And I have some NSX stickers over here, so if you ask a question, we can give you one. And by the end of the session, you can come and collect the stickers if you want to. Okay, Roy.
Thank you. So every year, the CNCF runs surveys and asks you as a customers, what are the challenges around the container initiatives? And every year, network and security getting a very high score around the challenge. And I would like to explore with you and maybe show you some of the challenge around container. So what you see on the left, it's a simple application, two-tier application. We have the front end and the back end. From network and security perspective, it's very easy to secure this application. I have only two IPs. I know where is the traffic is hitting, or where is the front end, what is the IP address. It's very simple. When we take this application and we broke it to a microservices-based application, so now all the monolithic process now are running as a container and communicate with each other. So from network perspective, the container or the pod inside the worker getting the IP address based on the worker they are running. So for example, we have the 40 subnet on VM1, we have the 10 subnet on VM2, and etc., etc. So if DevOps deploy a new feature, adding new microservice, the microservice will deploy, the scheduler will deploy the container on one of the VMs, and it gets this IP address. If we reschedule this container or the pod, it will change the IP address depending on where it will run. So this is the first challenge with the container. But the application is not just container-based. Most of the real applications are hybrid. So there is somewhere database, it can be VM or physical. And most of the time, there is a firewall between these environments. And here's the real challenge begin. Because the same pod, assuming you want to communicate with the database, we need to create a firewall rules to allow these traffics. And if we reschedule the pod will change its IP address based on the worker node it will run. So the same firewall is not aware of this change and will block the traffic. So this is the first problem. Let's talk about the traditional load balancer. We have the same problem, but in the opposite direction. The load balancer need to know where to send the traffic. So if the pod changing the IP address, you need to be aware of that. And we didn't spoke about the complexity of logging and monitoring this environment. So we have a lot of challenge around container initiative.
So I guess you heard a lot of challenges from Roy, And what we're trying to do here at NSX, just like how we solve the challenges for networking and security for VMs, we want to do the same for containers as well, right? So that's where we set off in NSX-T to create these new solutions to support multiple various containers platform solutions like Kubernetes, Pivotal Container Service, PAS, and if you have saw the announcement, PAS is going to start using Kubernetes as the containers platform, right? And then we also support Red Hat OpenShift as well. So your containers platform could be running an form factor of virtual machines running on vSphere or even KVM or even in bare metal hosts. We do support that as well. So what do you get end of the day, right? You get this single networking model, whether you are running only one of these solutions or multiple of these solutions. You get software-based load balancer as well as a distributed firewall, right? Why software? Because it's easily to scale out. We can handle high throughput, high performance, and especially when you need to scale the apps, your networking and security infrastructure will get scaled out as well. Last but not least, the day two aspect is also very important. We give you all the tools that you need to do, like, for example, monitoring of your environment, or trying to do troubleshooting and all this, right? So all these tools that the networking and security admin might be familiar with, we build it and for containers as well. Okay, so that's a high-level overview of like what we do at a container networking space. And then, right now we're going to get a little bit deeper, and the way we do it is like, we're going to do a role play. So I'm like from ACME Fitness, okay, to give you some background. I'm so-called the infrastructure director, okay, and I'm running a retail website selling fitness products. So if you guys want to buy some fitness products, you can actually access the website. I'm just kidding over here. So there's multiple teams supporting this website. We have multiple developer teams. We also have multiple operations teams, right? And then currently, the website is actually running on OpenShift container platform, right, a production website. We also have other teams that's starting to explore on upstream Kubernetes, right? So, and to my VMware architect, right, it says like the solutions need to support multiple container platforms. Okay, so what are some of the other requirements? So from security perspective, we still have physical database, and then it's being protected by perimeter firewall, right? So, we want to control access, especially when the Kubernetes ports is trying to access the database server, okay? We are actually using NSX today for the VMs. So when it comes to ports, when it comes to containers, we want the same security model to be applied for both VMs as well as containers. We're using a whitelisting model, so that should be applied to containers as well. Then more recently, the security team also come in and say, hey, we have some security tools that we want to run in the environment to scan the environment. And then if the port or the container is running behind some net, you introduce some challenges, right? So, if you are able to route the traffic natively from the ports, and then our tools can actually scan the ports directly. So that would be very good. On the manageability perspective, since we'll be running multiple platforms, we want this single SDN solution to support both OpenShift clusters as well as the Kubernetes clusters. Today, we don't have much automation on the load balancer, right? So every time when a developer requires to spin up some apps, they have to put in a ticket and says, hey, you need to do all this for me. And there's a lot of requests. My team actually cannot handle all these requests. So really, you need to think about how to automate, for example, layer 4 load balancer as well as ingress that a developer actually wants to use. From the flow monitoring perspective, today we don't have much visibility into our environment, right? We don't know what's the container flow and communication flow and all this. So if you are able to provide me with some NetFlow or IPFix capability, that would be very, very good. And today, because we are already using NSX microsegmentation, right? So they are familiar, the security team are familiar with that. But then the developer says, hey, they want to use network policies, right? So the solution must be able to support this hybrid model over here. From the availability standpoint, our physical network is active-active, equal cost multipathing, so the SDN solution need to support these active-active requirements from here, right? And I believe at a certain point in time that there could be both OpenShift cluster as well as Kubernetes clusters running. So if my apps is running at both clusters, if one cluster goes down, the other cluster must be able to take over, right? So they provide a high availability from here. And my team is growing. The website is good business, have a lot of customers. So the namespaces requirements also increases. So we need to support a huge number of namespaces, 2,000 namespaces. And then we are doing SSL offload from the load balancer. If there's any load balancer, right, we need to make sure that it's able to handle this 3 gig of throughput over here. So Roy, can you come up with a solution?
Yeah, I can try to mimic all these requirements in the time frame that we have. So from high-level perspective, let's try to figure out how we're going to do it. So what do you see here? Let's start from the top. The mouse here. So this is the physical router, this is the physical world, and this is where it ends. Below that, we start with the NSX components. This is the gateways, the tier 0 gateways. Both of them will run as active-active as per your requirements for maximum availability. That means both of the logical router will send and receive traffic. Okay. In terms of the cluster that you have, I understand that your production running on top OpenShift and some team explorers start to explore Kubernetes. So we will use single SDN to provide network services and security for both of the cluster with a single fabric. In terms of requirements for amount of namespace, this is a huge amount of namespace. So what we are going to do to achieve this goal, we will run a single tier 1 logical router. This is the gateway that will serve the OpenShift cluster. It's a single, and all the namespace will represent or create it as a logical switch. The same concept applies for the Kubernetes. It's a single shared tier 1 gateway. The same gateway, the same tier 1, will also provide the load balancing services. So just to give you the idea, all the services will run on the tier 1, the NATs, the load balancing, because on the top, the gateway running in active-active, they cannot run any services because it's a lot of gateway that traffic can hit the first gateway and return from the second gateway. It will be asymmetric routing, so we cannot run doing any load balancing services there. So we put all the services on the tier 1 gateway. And to answer the requirements of the disasters, we will create another VIP or load balancer that will decide how to send the traffic to the OpenShift or the Kubernetes. There are different ways, and I will show you what are the options during the demo. Let's break up the requirements one by one. So let's talk about the networking, how it's going to work. So what you see on the left, this is what the DevOps team doing. The first thing, when they want to deploy application, they create something called namespace. It's a tenant inside the cluster. When they create, for example, namespace full, what NSX will do, it will assign CIDR block from a big chunk, and it can be CIDR of 20/24, but it can be something else. You can configure, tweak this, okay? But if you remember the problem that we spoke about that on the beginning, that container changing the IP address all the time based on the node where they're running, with NSX it's not working that way. The pod inside the worker node can run on any worker node. We will guarantee that this segment will stay with this IP address, okay? So this is the first benefit of NSX. The NATs, this namespace will be NATed by default, but since one of your requests was to provide a no-NAT services, we can create with NSX another namespace, and we annotated the namespace, and based on this annotation, NSX will understand that this is no NAT namespace. So the second namespace assigned another CIDR, but this time it will not NAT it. And this will answer the requirements that if you have a security device somewhere like Nexus or some IDS, IPS that want to scan the pod from outside, you can reach to the pod directly because the traffic is routed. There is no NAT between the pod to the physical layer. Let's talk about the physical firewall problem that we show. So when we NAT the namespace full, we can force the IP or declare that this is the IP that we want to NAT. And we can make this IP persistent. That means that all the traffic from the pod, when they traverse the physical firewall, the firewall will see only this IP address. And we can create the rule and forget about this because NSX will make sure that this IP will never change. By the way, this is NAT is per the namespace. So the namespace full have this IP address. NSX can do the NAT per Kubernetes or OpenShift services. So if you have like just the MongoDB services that you want to provide or front end specific service, we can NAT based on this Kubernetes service and not the all-wide namespace. So it's another benefit. Let's talk about security inside the cluster or between cluster. With NSX, we can create a security policy, and the security admin can define the policy. Let's talk about a very simple use case. I don't want the OpenShift cluster will be able to talk to the Kubernetes. By the way, it can be, of course, in this example, it's OpenShift and Kubernetes, but you understand that it can be two OpenShift or two upstream Kubernetes, just for a simple use case. So with NSX, we can create a simple rule that blocks all the traffic between these two clusters. In the UI, we define the source and the destination as a NS group, security group, and then based on the labels, the pod are labels. Based on this label, we can declare and says all the pod that have this label will be part on this group. So this is just a screenshot of IP address that are part of the pod IP address. You understand that if the pod changing the IP address, the label will not change. So the IP address, the IP address will reflect automatically to the NSX. So any change, new pod that we have will be part of this security group. So NSX aware of all this changing all the time. So this is predefined rule. So the security team can go and create this rule. And this is the first requirements. But the DevOps team don't want to wait to security admins to create the rules. They want to work fast. The way we can do it is with something called network policy. The names may be sometimes misleading. It's a security policy. It's a firewall rules that you are defined in YAML. So we can create any firewall rules with network policy. For example, deny all the traffic, allow all out. It can be any rule that you want to create. And this is an example for a network policy rule. At the first time, it's a little bit tricky to understand what this rule going to do. To understand network policy constructs, it's not intuitive. So what NSX do, when we create this network policy, NSX create a DFW rule. So the enforcement for this rule will be inside NSX. But on the same thing, another thing that we are doing, we are reflecting this network policy that we create on DFW to the UI of NSX. So that's why a human being like us can understand what this rule going to do. You can see very easy that the source is any, the destination is the ACME namespace, and it's a drop. Okay? So security auditor can understand what DevOps team doing with network policy with that idea. And by the way, it's not, we can work with both of the solutions. It's not that you can work only with predefined rules or network policy. We can work with both of the methods, and this is the hybrid mode. So this is conclude the security requirements. The last thing that we would like to talk is about the load balancing. With NSX, we implement the load balancing not as a pod, okay? Because some vendors provide load balancing as a pod, the way to get to attract traffic to the cluster. With NSX, the load balancer can be VM, virtual machines, or even bare metal. That means that we can provide very high performance for the load balancing. Load balancing can be a bottleneck for big environments. So we can provide the SSL offload and achieve your performance requirements. NSX can support layer 7 load balancing. In this example on the left, you can see that based on the URI, if it's full, it will send to the pool number 1. If the traffic is URI is bar, it will send it to pool number 2. And please remember, if the pod in the pool changing the IP address, NSX know it immediately that they're changing, will know where to send the traffics. Another method to create a load balancing is a layer 4. We call it in the industry Svc Type Load Balancer. This is something very familiar in the public cloud. So when developer creating Svc Type Load Balancer rules, with NSX it will create a rule with virtual server IP, and based on the UDP or TCP will know how to send the traffic to the correct pool. So I believe, Vincent, we accomplished all your requirements.
So, good job, Roy, but you show me a tons of slides, and I'm not sure whether is it going to work in real. So, will you be able to do a demo for me later?
I can try.
Okay. Okay, now I'm going to switch head back to become a VMware employee and not a customer anymore. And we'll talk about like what's really under the hood, what's the secret sauce behind making all this happen behind the scenes, right? We'll talk about architecture. So it's called NSX Container Plugin. Basically, it's in short NCP. So what it does in a very high level, what it's trying to do is, watching the Kubernetes API and then says, okay, what are you trying to create? What application you create? And then we will actually translate that into NSX-T objects, right? So give you an example. For example, if you are creating a project in OpenShift or you create a namespace in Kubernetes, we'll create a respective T1 router automatically. And then if you have a net, we'll configure SNet and all this, right? So this is all done automatically for you, right? You do not need to configure all this on the right. So that's the job of NCP. Another example, if you saw Roy talk about the network policies, right? So that's a YAML file that you push into the Kubernetes clusters. NCP will actually translate that into NSX distributed firewall. Same thing for load balancer, whether you are configuring layer 7 ingress or you are doing a service type load balancer, right? NCP will do that respectively, right? Layer 7 or layer 4. Okay, so moving on to the what's really mix up of NCP, right? So you have NCP is basically running as a port. It's watching the Kubernetes API and then translate all the create all the objects in NSX-T, okay? In NCP, there's also other components as well, right? So let's take a look. So one of it is the NSX node agent, right? It's a port, and there's also a container called NSX node agent running it. So what is its job, right? Is like you need IP address, you need MAC address, you need VLAN tagging, right? I will talk about VLAN tagging later on. Basically, the job of the node agent is to take all this information from the hyperbus, right? Hyperbus is what you've seen, like VMK50, the secure channel between the hypervisor as well as the node VM. It takes all this information from the NSX manager through the hyperbus and pass it to the node agent. And node agent will take all this information and wire it down to the OpenvSwitch configuration. And that's how, all these things, how the ports get IP address and all this, right? That's how it works. Then we also have this CNI interface. So basically the kubelets needs to communicate with the node agent, right? So we have this CNI, NSX CNI interface, okay? We also have this NSX kube proxy is also running as a container. So what it does is basically replaces the default Kubernetes kube proxy over here, okay? And then what it does is basically translate the Kubernetes service cluster IP into the OpenvSwitch configuration. Right, I talk a lot about OpenvSwitch, and I will have the next slide to show you what is it all about. So if you have saw Roy's slides on talking about supporting network policy, and that is actually distributed firewall rules, right? This is how it actually works behind the scene. So if you understand NSX, the distributed code is actually running in the hypervisor itself. It's shown in the host over here, okay? And then you have the node VM is basically, you're running Kubernetes in VMs. You have a service running in VM. And the ports, the blue with the Docker container icon is the ports, right? So each individual port has a single IP address. So what we want to do is, we want to treat containers like VMs when we do security. So what we do is we attract all the traffic out to the hypervisor, and then we can apply the same distributed firewall at the hypervisor to the port traffic as well. So end of the day, what you can actually do is basically microsegmentation at the port level. And you use the same microsegmentation or distributed firewall technology for both VMs as well as containers. So your firewall rules perspective, you can actually apply it to both, containers as well as VMs. So this is what we're trying to do over here at the OpenvSwitch. We have many customers asking us, like, why do we actually have to replace the OpenvSwitch and all this, right? Or why do we have OpenvSwitch? And this is the reason why. In NCP, we make some installation improvement. And why we say improvement here? So if you have done any installation prior to NCP 2.5, you'll know that there's actually a few steps. And you see the components on the last slide or over this slide. There's multiple components over here, like OpenvSwitch as well as CNI and all this. So there's multiple steps in the installation you need to do. So in NCP 2.5, we created this additional port called the NSX NCP Bootstrap. So what it does, it takes care of the installation of the NSX CNI plugin and OpenvSwitch. So this single YAML file that you actually now need to use in NCP 2.5, you can actually bring up all the different NCP components. Right, really makes the installation process much more seamless today. We also created a new container in the NSX node agent. So basically what it does, NSX, it will provide the control plane for the OpenvSwitch. So if you want to look at the configuration of OpenvSwitch, you can log into the NSX OVS container, and you can actually look at the configuration from there. Okay, so basically I cover the components so that when Roy is coming in with the demo, you'll see some of these components and you know what is the role of all these components, right? So Roy, show me the solution.
Yeah. So about the demo, it's the same topology that we showed before. So we have the gateways running in active-active, and we have the OpenShift cluster and the Kubernetes cluster. I would like to give a credit for a friend of us, employee of VMware. His name is Dumlo, and we take his Dumlo works and document all the process of the installations and put it in the GitHub. So if you really want to follow this demo and do it in your own lab or in your environment, you can use this GitHub repo. So what we are going to do here in the demo is taking all of the instance requirements and making it in a real demo. Let's starting by switching to the. So this is not a video; it's a real live environment. What you see here is this is the vSphere. We create the OpenShift cluster. We have 2 infra, 3 masters. NSX will be the load balancer for the masters, of course. We have 2 nodes. The second cluster, it's PKS Essentials. If you are not familiar, what does it mean? It's an upstream Kubernetes, okay? Vanilla Kubernetes, as we say before, upstream Kubernetes. So we have here 2 clusters. We intentionally choosing OpenShift and Kubernetes to show you that can NSX manage both of them, okay? But I believe in your environment it will be all OpenShift or all Kubernetes. But it's more interesting to make it more complex. Let's go to the UI of NSX. What you see here is NSX 2.5 is the new version. And all the objects that you are going to see that creating here in the demo are going to reflecting in the network tab and the security tab. This is the new tab and for the policy API. If you are familiar with the previous version, it was all the network and security was here in the advanced and network security. This is the old API, okay? Just to give you the idea. So let's start to discover what we have before running any application. We're starting with the tier 0. We are showing you that both of them are running in active-active modes. So that means that the tier 1 gateway we are using shared tier 1 gateway. One of them is for the Kubernetes cluster. The second one is for the OpenShift cluster. We have 2 more gateway, but I'm using them only for the management traffic. So let's focus on this gateway, the Kubernetes and the OpenShift. Let's start to do some stuff. So let's start with the OpenShift. Let's discover. Oh. It's running. So this script helped me to run all the commands. Yes. So this is the node environment. You can see what we saw in the vSphere. You can see it from the CLI. We have 3 master, 2 infra, and 2 nodes. The namespace, the default namespace, one of the namespace is NSX system. This is where we put all the NSX source inside this namespace. We can see the pod inside this namespace. One of the pod is the NCP that create all the magics. The other pod, it's what Vincent explained us, are the bootstrap. We have a bootstrap per node. And the bootstrap doing all the installation and the lifecycle. When we say installation and lifecycle, if you add a new node, you don't need to do anything. NSX will install all the bits and what it needs to make this node part of the fabric of NSX. And this is huge improvement from the previous version. Okay? Let's create a project. It's a namespace, okay? In the Kubernetes folks here, a project is equivalent to a namespace. Before deploy or create a new namespace, let's focus on the OpenShift. As you can see, I have only 9 logical segments. So let's create the new ACME project. It's created. And let's refresh the UI. And this is where NCP start to work. NCP see that's a new object, and it needs to do some works and go to the NSX and create some stuff. So we create a namespace. In the shared tier 1, because it's a shared tier 1, we are not creating another tier 1 gateway in this POC, demo, but be aware that you can always work with multiple tier 1 per namespace. But in terms of the scenario that we want to achieve 2,000 namespace, this is the way to achieve this goal. Okay, so I create an ACME namespace. You can see the CIDR block assigned by NSX to this namespace. Be aware that all the objects that created on Kubernetes and OpenShift reflecting to the UI of NSX is really helpful. Let's see the NAT rules.
Hey, just to add, Roy, like previously when we have like single T1 for per namespace, when you click on the T1 routers, you get like, wow, there's so many T1 routers, right? It's hard to visualize and all this, although you can use the search. But now I really like it. It's really clean, you know, if you use a shared T1 model.
Yeah, thank you, Vincent. So let's searching for the ACME. Here it is. You see, when we create the namespace, if we don't annotate it, it's S-NATed. So this is the CIDR, and you can see the IP address of the NAT object. Okay? Now let's deploy an application. This application, the ACME Fitness, created by Pivotal folks and VMware folks, this is the YAML that describes all the services of the applications. It's a lot of configuration. But NSX can understand that when we create or deploy these YAML files, there is a lot of pod and services that are going to create it. NCP will see all the objects in the etcd because he watched the etcd and will start to do things behind the scenes. So as you can see, the pod already running. So if we go now to the ACME logical segment, it's equivalent to logical switch for people from the old version. So this is the logical switch. What we expected to see on the OpenShift ACME, here it is. Okay, we have the logical switch, and I'm going to see all the pod, the OpenShift pod, deployed on that logical switch. So be aware, the pod names exactly how they created on the OpenShift reflecting to the UI. So it's very easy to search the pod. If the developer says to you that this is my pod name, you can search it with NSX. And also, another benefit, you can see all the tags. So this is the labels from the OpenShift. So all the labels that we have in the YAML reflecting to the UI, and based on this label, we can create a policy. So the next thing is to create a load balancer. We have 2 options. Let's start with the service type load balancer. So I have the YAML that defined the kind service, and this is where it says that it's a load balancer, service type load balancer. That means it's a layer 4 load balancer, and you can see the port is 3000. And another interesting thing, instead of choosing just random IP from a big pool of the load balancer, we can force the NSX to use this IP address. And by doing this, we can guarantee that this will stay the IP address even if we delete it and recreate the service type load balancer. So if you remember, the physical firewall is another way to deal with this problem. So we create the service type load balancer. Let's go into the load balancer, to the virtual server. This is the VIP. And you can see it's created right now. It's a layer 4 TCP. The port is 3000. Let's open this. Okay, we can see some statistics. Before explore the statistics, I am open the browser, and this is the applications. Let's view the statistics. With NSX, we have a lot of statistics around this load balancing. Okay, we can see that we have hit counts. And what is nice about that, we can see the pool member. This is the pod. This is where NSX send the traffics. We can see it from here. Of course, we can see it from the CLI. If we describe the VIP that we just created, this is the IP address of the VIP, and this is the endpoint. This is the pod that's receiving the traffic. Why it's important? Because now if we scale and we add more replica, that means that NSX need to be aware of this, because this is another pod. They need to send traffic to the new member. So if we are going to the UI, we wait a few seconds refreshing, we're expecting to see another pod created here in the NSX. So everything that you are doing in the Kubernetes or OpenShift reflected immediately to NSX with all the labels. So let's create now layer 7 rule. It's called ingress. In OpenShift, it's routes. This is a layer 7 ingress. This is the URL. It's frontend.lab.local. And we send everything. We do a wildcard. Everything is going to the front end. It's the same front-end pod, but this time with the layer 7 rules. We're creating the ingress. We can describe it. Yeah. Now let's go into the UI and see how it looks like. This is the rule. The layer 7 rule should be here. I'm refreshing the UI. Refresh. Yeah. One rule created. And this is the layer 7 rule. So there is a UI here that shows you this is the client and this is the request. And what NSX is going to do is rewrite the request and send it. So the request is sent to frontend.lab.local, and you can see where NSX will send the traffics. So it's nice UI that you can understand what developer creating and all the objects reflecting to UI of NSX. So this is the OpenShift. Now we are jumping fast to the Kubernetes cluster. Hopefully the strip will start to work. So now I'm creating the namespace, but this time I want to create the namespace without nuts, so I'm annotating the namespace, okay, no snut. Let's create this very fast. So we created a namespace. Let's see what's happened in the UI. This is the Kubernetes. We have 5 logical switch. We can see that ACME is created. This time it's a different segment. It's the Kubernetes. And to prove you that there is no NAT here, I'm going to the NAT area and searching for any new entry on the Kubernetes cluster. You will not see any entry as NAT rules created for this new namespace. So this is prove you there is no NAT. All the pod traffic is routed. So now you can using the security tool to scan this segment or whatever you want. So we want to deploy the same application, and the ACME application. So we are doing it very, very fast. The same thing, the same concept like the OpenShift is here. We can see that the pod is running before continuing. It's created them. Okay. Let's continue. Now let's create a service type load balancer in the Kubernetes. It's a load balancer, but this time the IP address, I decided to use different IP address. Okay. And to make it, to understand, because now I want to send traffics, and sometimes I want to send this traffic will go to the OpenShift cluster and sometimes go to the Kubernetes cluster. So of course we created with different IP address, but to make it more reflected in the UI, we use different version for the Kubernetes, and in this version, you will see the web page a little bit different. Sometimes it's like, let's see that the entry is created here. Yeah, it's doing it right there. Oh, okay. So this is the front end, the same application, but this time you see there is items that you can see are different. This is the OpenShift. It's start with 10.40, and this is the Kubernetes. And the IP address is just important for the demo, because right now, what I'm going to show you, I create a new VIP, and this is the IP address of the VIP, okay? Let's open the VIP. Okay? And the next question will be, what is the method, how to send the traffic, the decision how to send the traffic to the Kubernetes or the OpenShift. We can see we have the OpenShift VIP, the Kubernetes VIP, and you can see I decided to do it with the weights. So we can choose a round robin, but with weight you can mimic like percentage, like 80% of the requests will go to the Kubernetes and only 20% will go to the OpenShift. Okay, but let's try to see if it really works. I will try to refresh. Okay, now it's the Kubernetes, and now it's the OpenShift. Then refresh really fast, so I'm generating traffic. The last thing that we would like to add to this demo is around security, and also demonstrate the catastrophic failover. So what I'm going to do, I'm going to create a network policy. And this network policy will block all the traffic to the OpenShift cluster. And by this, I'm going to mimic a catastrophic event that the OpenShift cluster is not working anymore. Before creating the rules, let's see what are the existing rules in the DFW UI. If you remember, there are two methods how to create rules. The predefined rules, I created them here. So OpenShift cluster cannot talk to Kubernetes cluster with a drop. So I blocked everything. You can see, by the way, if I click, you can see all the IP address of the pod are here. Okay. Now let's create, and this is, we create two sections. It's called container top and bottom, but you can name it whatever you want. But it's important for the network policy, and we can decide where this new object will be created in the UI. Sometimes it's important because when the way traffic firewall works is the order is matter. So the security admin will be always on top of the developer. This way we can enforce and compliance that if I want to block OpenShift not to talk to Kubernetes, I need to be this rule on the top. Okay, so let's really fast create the rules. So this is the network policy, a YAML file. Let's create and deploy this YAML file and refresh the UI. And immediately a new object will show up. And you will see that the source is any, the destination is the namespace, and it's a drop rule. So what we just create, we block all the traffic to the ACME namespace. So if we try to go to the OpenShift VIP, I'm trying to refresh, you will see there is no response now. But for the VIP, if you remember, we have a VIP that represents both OpenShift and Kubernetes. All the traffic now, by default, will go to the Kubernetes, and we simulate catastrophic event right now. So just to conclude, it was very, very long demo. Thank you for your patience. So with a single fabric of SDN, we were able to demonstrate that we can work with OpenShift and Kubernetes. It's a different orchestrator, and we can work with both of them in parallel. So NSX can really work with multiple clusters. Compared to other options that you have in the market, it's very difficult to achieve this goal. Thank you.
So, Roy, so if I'm the customer, I'm going to place a PO straight away, right? Okay, so let's switch back to the slides.
Yes.
So now we're going to talk about like, some of the new things that we have in NCP 2.5. It was released in September, right? So it's already, if you have the license, you can actually download it, okay? And before we go there, we also have NSX-T 2.5 already GA, and there's a huge improvement in enhancement in the load balancer. So you saw a lot of Roi's demo is actually using load balancer and all this. We actually make a huge enhancement, especially on the performance side of the load balancer, right? So if you can see now, our HVMs can actually support much more instances right now, right? So how you actually read this table, the first table, is on the left-hand side, it's the size of the HVMs. So our HVMs comes in two form factor. You can run it in VMs with different sizes, which is basically different resources tied to it. We also have the bare metal H if you really want high performance for load balancer, right? And then on the right-hand side is the number of instances of load balancer that you can actually create. So you saw like, Roi actually created multiple instances of load balancer over here. So previously in 2.4, especially when you are doing a proof of concept, you create a small HVM, you do not have much resources, you can't even spin up a load balancer instance, right? And in NSX-T 2.5, we changed that. We allow you to create one load balancer instance now, okay? On the bottom chart, you can see from here, it's showing you an example of what is the maximum of virtual IPs that per load balancer instance supports, okay? So for example, in 2.4, it doesn't change much over here. So each load balancer, small load balancer, we can support 20 virtual IPs and 60, in terms of pool numbers, it's like 300 per load balancer. So if you want the full details, we actually have document down everything in the config max. You can actually give the links over here, and then our, one of the TPM, Dimitri, actually created an encyclopedia on the load balancer, as well as, some of the TOI, transport information of the scales and all this. You can actually find it in the NSX community website. So I urge you to download it. The encyclopedia is 200 over pages. They basically tell you everything about the NSX-T load balancer. Okay, highly recommend for you to download it. We're going to talk about some of the changes in NCP 2.5. If you have heard, we actually uses a single YAML file to do the installation right now. So there's no need for you to change something in the Ansible host file if you are doing the OpenShift installation. So just to give you an example here, you still need to configure the IP address pool, and IP blocks. So that's where the containers as well as the load balancer will get the IP address from. So now in NCP 2.5, we support the policy APIUI, which is the simplified UI on the left-hand side. So this is how it looks like, right? You can go there in IP management, IP pools to actually configure all this. Okay, so very quickly, this shows you the relationship. Like you create two IP blocks, one for the containers and one for the no SNet pool. So they will actually pool the IP address block respectively from these two blocks. Okay, I also give you a diagram. So what it actually shows over here, from IP pool, that's where the SNet pool or the net pool, the net address comes from, as well as the load balancer VIP. Okay, so that's called, I call it the IP pool external over here. And basically you just take the name and put it into the file. That's all you need from the configuration standpoint. So many customers ask me like, hey Vincent, what's the difference between IP block and IP pool? So the difference is IP block, every time you request from it, it gives you a CIDR range, a block of address. IP pool, it dishes out an IP address every time. So that's basically the difference between these two, right? Very simple. Okay, so that was on NCP 2.5, but if you still have NSX-T 2.4 environment or you still want to leverage 2.3, 2.4, in the VMworld US session, I actually talk about that installation. You can actually watch the recording. I put the link up for you guys. Okay. So whether you are using 2.3, 2.4, or even 2.5, you still need to do, this is still a configuration step that you need to do. You need to do the tagging. You need to let NSX-T know which is the container interface, right? Two tagging that you need to do, the node name as well as the cluster name, right? And you have to do it for each of the nodes, right? So if you have 7 nodes, you have to do this 7 times. Okay, so we will come in and share our experience on what we see in the field. Okay. First, we'll start off with, so in OpenShift clusters, there's some default ports that will actually needs to communicate with the node. This is what I am referring to. Right, so this system ports over here actually needs to talk to the nodes interface. So if you have like a router or a firewall in between, right, many times you actually forget that you forget to put the policies inside there, and when the ports is trying to communicate, the firewall will actually block the traffic. So that's where you see like ports are not created properly and all this, right? It's because you might not have put in the firewall rules. So when you're doing the integration, okay, you actually need the credentials to the NSX-T manager, okay, and especially when it's a different team from the NSX-admin. The NSX-admin might not want to share the password of the manager to the DevOps team or the platform team, because you can do a lot of changes to the NSX-T environment. So what you can achieve here is we have this VIDM, is Identity Manager, but that is only for you to create users to log into the NSX-T manager. If you do that, you realize that you do not have access to the API. But what you need to do with the integration, you need access to the API. And so what we do is we use certs to do this. So in NSX-T, you can see we have this super user principal identity. This is what we're talking about over here. You create this certs, and then when you're doing the integration, you just put all the certs on the nodes, right? Then you will have the integration, and the NCP is all set up properly. So I have recorded how to do it in a step-by-step in the video. You can find the link over there. In PKS Enterprise, since version 1.2, we actually make it as a default mechanism. You have to create a principal identity. So the link over there, there's some scripts over there. You can actually use the scripts to really create this super user identity really quickly. Okay, wait.
Yep. Some of my experience that it's happened to me a lot of times, and my colleagues, I call it the double tagging problem. So what I'm going to describe here is that assuming that you deploy the edge as a virtual machine, okay? And inside this edge, we have the gateway, the logical gateway that want to communicate with the physical environment. So you want to achieve these goals. So the problem is that this virtual machine, the edge, you have an option to create something called uplink profile. Inside this uplink profile, you have the option to put a VLAN ID. So all the people put VLAN ID there. But then you realize this is an edge, this is a virtual machine. You need connectivity in vCenter, so you create a port group and attach the port group to this edge. And by the way, in that port group, you put the VLAN ID to provide the connectivity. And this is, you will face the double tagging problem. Why? Because you tag inside NSX-T, and then you tag in the vCenter in the port group. You tag the traffic twice, and it will not work, and it can make you crazy. It's happened to me in my first POCs and colleague of mine. So this is one thing that I want to share with you. Another issue that I see it a lot of time in POCs, that people try to do shortcuts. What is the shortcut? They don't have many VLANs for the POC, so they try to install NSX with 1 or 2 VLANs. And what they're trying to do here, what you see is the management VLAN, and they put the tier 0 and connect the tier 0 on the management VLAN. Technically, it's possible. But in container environment, you may face this issue, because there are pods that's running inside the cluster. And most of the time, this pod needs to communicate outside. For example, I put the NCP pod, and the NCP, as you know, need to communicate with the NSX manager. NSX manager is not aware of the pod IP address down there. He just knows one thing. I know what is my default gateway. And he sent everything to the upstream router. This is his default gateway. The router will send the traffic to the pod, and everything works. But this is not how it works in real environment, because most of the time in your management environment, it's not a router. It's a firewall. And now, when these traffics will hit the NSX manager send the traffic to the firewall, and the firewall was not aware of the initial request. It's an asymmetric problem. He didn't saw the request coming through him, so we will block these traffics. and it can drive you crazy, this problem. So the way to really do it is create separate VLAN for the tier 0 and separate VLAN for the management. And this way, if it's a firewall, you will be able to pass the traffics. Don't do shortcut on the tier 0 uplink, guys.
Yes, this one is very common, right? So I face it all the time because POC, asking a network guy to create VLANs is very hard, and then you try to take shortcuts and you will find out like, oh, why is it not working? And you spend a lot of time troubleshooting. So do pay attention to this. Yeah.
So the last things, because we don't have really a lot of time, is to talk about IP address considerations and designs. It's happened to me with customers. We installed the Kubernetes clusters and things are not working, and we try to figure out why it's not working, and then we realized that previously they deployed the vSphere environment with the IP address of the pods inside the Kubernetes. So this is just one example of mistake, yeah? But be aware, there are a lot of addresses that are reserved in the PKS solution or OpenShift solution that are reserved IP address. Don't use those addresses in the infrastructure. I know it makes sense that you see it, but when you are reaching to customer environment, you have no idea what are the IP addresses out there. So be aware there are reserved IP addresses.
Yeah, so do check this, because like if you don't check this on hand and you start creating stuff in NSX-T and you realize that you need to change IP address, you have to like redo everything again, right? So it will take you lots of time. Right, so this is really important. I face it in PKS as well as OpenShift when customers are doing this and they are using the range over here.
Okay.
Okay, so interest of time, we will just quickly show you the slides, but you can download the slides later on. This is basically just reference material. So Yatsen is the TPM, technical PM for the CNA container networking app space in NSBU. So he created installation videos step by steps. I did some videos as well with enterprise container platform, OpenShift container platform. You can take a look over here. Roy actually part of this demo. He created using NCP 2.5. I actually download fork from his GitHub and I just put in my environment and I can quickly run up my OpenShift clusters with NCP 2.5. So he put up, he shared it here as well, so you can actually download all this. He also did a demo on upstream Kubernetes. So the NCP for upstream Kubernetes is also over there. You can actually take a look. We have a very good, oh, sorry. Okay, no problem. So there's a reference design guide that we written maybe 1 year back already, but it's still very good documentation. I use it a lot with my customers. PAS as well as PKS. If you need a reference design guide, you can actually download the guide, right? The TPM, Yatsen, he did a session, so we cover NCP on a high level from a solution perspective, but if you really want to know the nuts and bolts about NCP, do watch the recording from Yatsen, okay? All right, so in summary, NSX container plugin provides tremendous value in solving some of the networking and security challenges that you have seen, right? We've shown you from the requirements perspective, from the solution perspective, we also give you some tips. So how to streamline the networking and security into your container solution. So we hope that after this session, you can start considering, installing NCP in the environment, and do share your feedback and experience with us. We really want to understand your experience and how we can actually make this better. We put our Twitter and LinkedIn over here. You can actually find us, or we are still sticking around after the session. You can come and speak to us if you would like to. If not, we still have time for questions?
No.
No time for questions, but we'll stick around. So thank you very much.
Yeah, and
there's some stickers over here if you want the stickers.